Alright, class. So this begins the new unit, Unit 3, on processes in Earth's energy. So teaching point, please copy this down into your notebook to explain the relationship between wavelength and energy in electromagnetic radiation. For this lesson, you're going to be needing your reference table as well, and a word that should pop out at you would be electromagnetic radiation, which can be found on page 14 of your ESRT. Launch for today using your prior knowledge, compare and contrast stars with planets. This picture is a great picture too, by the way. So, picture the sun, and this big ball of flame is a solar flare. And solar flares eventually end up as being part of our solar wind, and Earth has a magnetosphere, which can help with pushing this radiation aside and not harming us, which is great. Alright, pause the video here, think about the launch, and I will give you some answers right now. Okay, so thank you for pausing. So using your prior knowledge, compare and contrast stars with planets. So one major thing here is stars give off light. Planets don't give off light. Planets can absorb that light or reflect it as well. Like I was mentioning in class with moons, when you have a full moon phase, right, the moon is 100% lit. But it's not, the moon doesn't give off light. The moon actually reflects a lot of light. And if you want an area brightly lit in nighttime, you would want to have a full moon phase. If you have like a crescent phase, it won't be as bright as a full moon phase. Alright, so a major contrasting point with stars and planets is that, again, stars can create light through nuclear fusion, right? It takes the lightest elements, the most abundant element, which is H, which is hydrogen, combines it to make helium, and eventually, over the course of time, heavier and heavier elements will be made. And once Fe, which is iron, is being made in a star, that's when we know a star will leave the main sequence and become either a giant or supergiant, and eventually will explode or become a white dwarf and then a black dwarf. Comparison, right? These are celestial features in space, right? So these are just celestial bodies that take up volume in space. All right, let's begin. All right, so let's copy this down. Nuclear fusion, the process by which lighter elements, for example hydrogen, combine to form heavier elements, for example helium. All right, in this picture on the left here we have a nebula, right, which is the formation of stars, right? So it takes a lot of gas and dust, combines them together to make this happen. In this color here, we have a lot of blues and some reds. Now, if you turn to page 15 of your reference table, ESRT, you'll notice on the x-axis up top by stars, we have blue on the left and red on the right. We have your higher temperatures on the left and lower temperatures on the right, which means that blue would be your hottest and red would be your coolest. In this picture here, this is a very hot making nebula, right, which is a lot of blues here near the center and reds further away. All right, telling you that it's very hot near the center and cooler as you leave that center. And that can be indicative of gravity taking control and making it hotter because of pressure conditions as well. In the picture here on the right, we have light hydrogen nucleus under high heat and pressure. They combine together, in which would yield, which is a chemical reaction, a heavier nucleus of helium, and energy is giving off. And we also have subatomic particles as well, that can be given off, but we have energy, we have sound, and heat. These are all things that are made through this nuclear reaction, right? This chemical reaction. Next, electromagnetic radiation. So radiation, let's get this definition down. The emission of energy in the form of electromagnetic waves. All right, and waves can go up and down, like how we have here in this picture. We have a crest, which is at the top, and then we have a trough, which is down below. So we have peak and a valley, peak and valley, and these are wavelengths. And the length of these wavelengths can change, and that will tell you what type of energy is being transmitted. All right, within that spectrum of light. All right, down below here we have the electromagnetic energy that has the properties of transverse waves. So this is a transverse wave. All right, there is an amplitude, right? There's a crest. We have a wave height, and we have also frequency as well too. So frequency is the amount of waves that pass through a given point in a given period of time. And if we think back to the Big Bang Theory, we mentioned that for a redshift to happen, right? So the red light color has longer waves, and therefore would not have a high frequency. However, if you have a blue shift and a star is approaching planet Earth, and we have a spectroscope to measure this, we can figure out that the wavelengths, right, would have a higher frequency for the blue shift. All right, so energy that has properties of transverse waves. Okay, again, we have a transverse wave here. We have peaks and valleys, and same picture here about nuclear fusion on the right. All right, continuing. We have the electromagnetic spectrum, a range of electromagnetic wavelengths of either increasing or decreasing energy. So this is on page 14. Shorter waves are found here on the left, right? Decreasing wavelengths. We have gamma rays, we have X-rays, and UV. Every time I think of gamma rays, I think of the Incredible Hulk, right? Gamma radiation, right? So this is pretty intense. These would have higher frequencies and higher energies. Right. On the right side, we have increasing wavelengths. We have infrared, micro, and radio. All these will have longer waves and lower frequencies and lower energies. High energies can do a lot of damage to humans, right? We hear about when you go to the beach, you should always be protected, wear sunscreen, because the ultraviolet rays of the sun can harm our skin and can cause skin cancer. Right? Too many X-rays that you take without proper protection can also cause cancer. That's why whenever you take X-rays, let's say you go to the dentist, right, twice a year, they put a pad over your chest to protect your vital organs from that radiation. All right, and then visible light is right in the middle of the spectrum. Right, we have violet up to red. All right, let's do 2 quick assessment questions here. All right, first question. Infrared, ultraviolet, and visible light are all part of the solar spectrum. The basic difference between them is there. A, wavelength, B, speed, C, source, or D, temperature. Okay, please pause the video, answer the question. Once you answer it, right, hit the play button and hear the answer. Okay, thank you guys. So the basic difference here is their wavelengths, choice A. All right, number 2, which color of the visible light spectrum has the longest wavelength? We have A, green, B, orange, C, yellow, D, red. All right, please answer this question. Pause the video, and once you have your answer, press the play button and hear your answer. Okay, thank you. So we want the longest wavelength. So when you look at the longest wavelengths, we're looking all the way on the right side of the color spectrum. All right, it's either going to be violet or red, right? Violet has the shorter waves and red has the longer waves. So for number 2, choice D would be correct. All right, intellectual engagement. Do you think every location on Earth receives the same amount of energy from the sun? Explain. All right, think about this answer. Again, pause the video. Once you have an answer, hit the play button and you can hear the answer. Okay, thank you. So do you think every location on Earth receives the same amount of energy from the sun? Explain. All right, no, we don't. All right, if you think about sun's path, we mentioned that the direct ray of insolation, right? Insolation is incoming solar radiation, hits the tropics, right? Tropics are in between the Tropic of Cancer, which is 23.5 degrees north, and the Tropic of Capricorn, which is 23.5 degrees south. So we have the most intense insolation happening there, which means that you would have the warmest temperatures in that region. The further north you go and the further south you go, your temperatures will begin to decrease. All right, and then once you get up to the poles, it's going to be extremely cold. Right, that's where you have like your very cold air masses, your Arctic air masses. Right. So, does every location on Earth receive the same amount? No. All right, because the Earth has a curved surface. All right, you're going to have the most intense radiation when you have that 90-degree angle between the sun's rays and the surface of the Earth. All right, so we're going to have a task for Monday set up. I have these copies. I have some of these copies in my room. I'm going to send you a copy of this as well. So please make a copy of this, answer the questions, and make sure you submit this to the substitute as part of your classwork grade. There are 7 questions for this, which should take you no more than maybe anywhere between 7 to 10 minutes to answer. Once you've complete the activity, depending on my availability for tomorrow, I might set up another lesson like this tomorrow, or I'll be in school and teaching you the next lesson in this unit. All right, lesson summary, right? 3 important concepts we learned today. All right, so one major thing we learned today is about revisited nuclear fusion in terms of the energy given off by the sun, all right, called the electromagnetic spectrum. We learned today about the transverse waves, all right, how you can have different wavelengths of energy given off by a star. All right, and we learned also about page 14 as well. We have our decreasing waves on the left side, our increasing waves on the right side. On the left side, decreasing waves, we have gamma, we have X-rays, and infrared on that side. On the right side, where it's going to be increasing wavelengths, we have radio, we have micro, and we have infrared. And right in the middle of that, we have our visible light. All right, so ladies and gents, make sure you print out the activity, answer those questions, submit that to the substitute. Please work on those questions in class, okay? I have some of your lab books. All All right, and if you have other things to work on, please work on them in class. All right, have a great evening, and I will hopefully see you the next day. Bye bye.